One of the things we've talked about is phase changes, and if you read this a few times, you'll kind of hear what it's saying. It's saying if you take liquid water, specifically we're looking at 18 grams of liquid water. So this is 18.0 grams of liquid H2O. It says that you have to zap it with this amount of energy, which is 40.7 kilojoules, okay, in order to get all of that water to evaporate. So to get it all to evaporate. So this is showing my evaporation, okay. So when you're done, basically you won't have any liquid water there. It'll be a dry beaker, okay. So that's actually, I bet you by this that all substances have a specific amount of energy you need to zap them with in order for vaporization to occur. So we kind of have this sort of physical property going on with water. We could say for water, 18.0 grams of water, okay, is equal to 40.7 kilojoules of energy if what you're trying to do is to transition from a liquid to a gas. So that actually is a physical property. And then it goes on to say that how much energy would you have to zap it if instead of 18 grams, if you had 150 grams with 3 sig figs. So we're going to work this problem, and we're going to use the first term we're going to start with actually is our 150 grams. Okay, and then we're going to use this then to go ahead and get from grams to kilojoules. And I'll tell you that there's one more twist here. Kilojoules is energy. And notice that it wants to know how much energy in calories would be required. So here is your link, not from calories to kilojoules, but calories to joules. So it kind of, I'll show you when we get to that. We have a few steps on the end to kind of clean that up. But like this slide says, we can kind of think of the information that was given as for this as water requiring 40.7 kilojoules to vaporize 18.0 grams. So we kind of have these relationships. And I really encourage students to go ahead and pull these out from the problem to then kind of see how to use it like as a puzzle piece to get from the information given, the thing you want to convert, to where you want to get to be. So here we go. Let's kind of look at a roadmap for working this problem. We can go from the grams of water to kilojoules of energy, just simply using that 40.7 kilojoules is equal to 18.0 grams. Okay? We're going to put units of kilojoules on top, units of grams on the bottom, and that'll work for us. And then from kilojoules, we're going to have to go to joules, actually, because the relationship we have between calories is joules to calories, not kilojoules to calories. And so the kilo prefix always means that you have, it's always 1,000 times the base unit. So there's 1,000 joules is equal to 1 kilojoule. And then once we have joules, we're ready to go to calories using that relationship that you saw on the previous slide. And actually this is an exact relationship because it's by definition. We can go to calories from joules using this. 1 calorie is exactly equal to 4.184 joules. Alright, so here we go. The first term is going to be the mass of liquid water that we want to vaporize. So that would be 150 grams of water, liquid water. So don't forget that, read your story problems carefully. There was a decimal there, and that makes a difference because what? That makes this 3 sig figs, right? So I put that number over 1, and then I want to go ahead and introduce this energy per gram. I'm going to put that right here. I want units of grams to cancel, and units to be left with units of kilojoules. So this is what it looks like. Okay, now units of grams cancel. We have kilojoules there. Now we're ready to go ahead and go from kilojoules to joules using this relationship. So what do you think that looks like? looks like this, where we have 1,000 joules over 1 kilojoule. Now, grams have canceled, kilojoules have canceled, we have joules here. Now we're ready to go to calories. Again, we're going to put the units we want to be left with on the top, so put calories on top. The units we want to transfer on the bottom, joules, so these will cancel. And then just go ahead, and that's the way I do it, and go back in and bring down the numbers. So 1 calorie and 4.184 joules. Cool. Very good. So that's the last term. Now let's take one look at how we need to round this. Looks to me like we've got, I told you there is uncertainty here, 3 sig figs. There's actually uncertainty in both of these quantities. But I'm liking, what, 3 for both? Okay, no uncertainty brought by that within the metric system, and actually no uncertainty brought by that relationship. So, I'm liking 3 sig figs. Okay, so is this what you got? I went ahead and packed it up in scientific notation to kind of take out the ambiguity. So I got 3 sig figs there. Now, if we were going to unpack this, actually, we'd move the decimal place over 4 places. 1, 2, 3, 4. So it would be 81100 calories. So actually, you could go ahead and write this number too, because the way it is, as long as you don't put in the decimal, this by convention is also 3 sig figs. So either way here. So now we are on to maybe some of your trickiest problems yet, but just take your time, allow plenty of time. Now, you have to show all work, and part of the reason for homework, I think, is you must show your work. Part of the reason for doing homework is that we're on the same track with regard to what I expect on your test. Okay, and you have to use the factor label method. So it should look, your homework should look very similar to what the problems that we've been doing in lecture.